Okay, so first we're going to take a look at a quadratic here, x squared minus 6x plus 2. And then first we're going to find all the special parts, okay, the axis of symmetry, the vertex, and all of the intercepts. And then we are going to write it in vertex form. Okay, so what I'm going to do, because they specifically ask for each one of these, I'm going to use the formulas, the equations that we had last week. I'm not going to worry about doing completing the square too much. If you guys feel comfortable with that method, if that's the method that you prefer, if for whatever reason you just love completing the square, please go ahead and complete the square. If that's what you feel most comfortable with. But for class and for what I'm going to show you guys, we're going to do it the other way. So first, let's remember our our first equation for the axis of symmetry we can find, right? Remember, it's a line, it's a vertical line somewhere on the graph. And it's going to be h is equal to negative b over 2a. Now, again, this is nice because vertex form, right? That h is right in there. So when we find the axis of symmetry, we already have part of our equation. Okay? So just be careful with your signs. That's usually the part where people make the most mistakes. Okay? So usually what I like to do is I like to write down my coefficients, right? So here, because there's nothing in front of the x, my a is 1. My b term is the middle term. That's going to be negative 6. And we usually don't need it, but I'm just going to write that c is equal to 2, right? If we had our other form, ax squared plus bx plus c. For the axis of symmetry, we just need negative b over 2a. So that's going to be negative 6. Okay, so again, be careful there. Over 2 times a, and a is just 1. So simplifying this, when we have two negatives, they turn to positive. So we have 6 over 2, which is 3. So we have our axis of symmetry is the line x equals 3. And so again, if I was graphing this, maybe I'll sketch the graph over here while we're doing it. At x equals 3, I'd have this invisible line of symmetry. Okay, so that was our first part. Now the second part follows directly from this. Okay, I talked about this, but I don't think we went over it too much, so it's good that we're doing this now. What we're going to do is we're going to plug in h to our original equation. Okay, so we're going to find f of 3. So I can do this before we switch over to vertex form. Okay, and this is going to give me my k value. Okay, so I'll put that over here. F of h is going to give us our k, right? And that's what this is telling us too, right? Where on this line is my graph going to cross? Because it has to cross here at some point. So we plug in 3 squared minus 6 times 3 plus 2. Right, so again, just be careful with signs and your operations. We're going to have 9 minus 18 plus 2. 9 minus 18 is negative 9. Negative 9 plus 2 is negative 7. So my k is negative 7. So that would be probably somewhere down here. Again, this is just a sketch. All right. So we can say that our vertex is at the point 3, negative 7. Okay, so that's the first half. All right, so we did axis of symmetry and the vertex. Now this next part, so if you're asked to sketch a graph, finding the x-intercepts is a great way to do it, because for any parabola, you need 3 points to graph it. Okay, if you're just doing a line, you need 2 points, and obviously just connect the dots and there's your line. Anytime we're graphing a parabola, you need at least 3 points. Okay, so usually the vertex, and then the x-intercepts will give you a nice picture. So there's a few ways to find the x-intercepts. The first way I would recommend is try to factor this. Right, so you think to yourself, what are two numbers that multiply to 2 and add up to -6? Well, in this case, that's not possible. Right, the only multiples of 2 are 1 and 2. So if I tried to do, x plus 1 times x plus 2 or whatever, there's no way I'm going to get a -6 from any of that. Going back to algebra, what is the one way I can always find the x-intercepts? What formula can I use to always find the x-intercepts of a quadratic equation? Do we remember? Is that starting to look familiar? Okay, we can always use our quadratic. What's up?
What's that formula called again? I was like,
I think they just called it the quadratic formula.
yeah, that.
Okay, this is always a viable option for any quadratic equation. Okay, and here you need the a, b, and the c, so it's good that we have them labeled. Okay, so obviously, yeah, we haven't gone over this at all this year. It may be popping up again, so I'll be sure to remind you guys when, hopefully you have this memorized, but if not, that's okay. All right, so we have this, right? Let's plug in our a, b, and c. So we're going to have -6 plus or minus -6 squared minus 4 times a, which is 1, times c, which is 2, all over 2 times 1. So before we do this, okay, one thing that this tells us if we're going to have real answers or imaginary answers. Okay, if we had real answers, the graph would go up and we'd cross the x-axis. If we had imaginary answers, our graph would go down and it would never touch the x-axis. Well, the leading term here is positive, right? It's a +1. So that's telling me my graph has to face upward. So we should end up with answers. Okay, if you end up with an imaginary number, something went wrong. So first simplifying this, -6 gives me a +6. Plus or minus, be careful, -6 squared is +36. 4 times 1 times 2 gives me -8, all over 2. So here we're going to have 6 plus or minus the square root of 28 over 2. All right, now, if you're just looking to sketch this, all right, this is really all you need. You can punch one of them into the calculator, right? 6 plus the square root of 28 times 2. But another thing we can do is we can simplify this. What was that? Oh, I got an email. Okay. So factors of 28 are 4 and 7. So we can take the square root of both. The square root of 4 is 2. Can't do anything with 7. So that becomes 6 plus or minus 2 root 7 over 7. Oh, no, I'm sorry. Over 2. Now, because each one of these is divisible by 2, I divide everything by 2. And this gives me 3 plus or minus the square root of 7. All right, so those are our x-intercepts. Now, don't forget that we have two answers here because of the plus or minus. So we have 3 plus the square root of 7, which will be, like 2 point something. And then 3 minus that 2 point something. All right, so over here and over here, 3 plus square root 7, 3 minus square root 7. All right. Now this last part for part A, the y-intercept, we didn't talk about really, but the y-intercept is probably the easiest. What you do for the y-intercept is you plug in x equals 0. All right, so we plug in 0 to our original equation. That's going to be 0 squared minus 6 times 0 plus 2. So our y-intercept is 2. Okay, or the point 0, 2. All right, so we did a lot there. Any questions with that part A? Okay. Then part B, once we've found all of this, to write it in vertex form is super simple because we already found everything that we need. Right here, I have my vertex. So 3, negative 7 is going to be the h and the k. Now the only other part I need is a. If we're doing it this way, your a is already given to you. The a in your standard or your expanded form is the same a in your vertex form. You don't have to do any extra work. Okay, I guarantee that will always be the same. So here our a is equal to 1, and we're just going to plug everything in to our vertex form. So we're going to have 1 times x minus 3 squared plus negative 7. And we're just going to make it look a little nicer. We don't need this 1 there anymore. So I can have x minus 3, oops, that's an x, squared. And then that's going to change to minus 7. And that would be our vertex form. You would get the same answer for B if you did the complete the square, right, with this formula. But we're running a little short on time, so if you'd like to do it that way, just email me separately and I can help you out. But that's probably a little quicker. All right, any questions there? All right, so let's take a look at one more example, example 2. Oh, wait, no, that's not what we're doing. Okay. So we're going to write the function in vertex form of a parabola with vertex -2, 5 that passes through the point 0, 9. All right, so again, the first thing I'm going to do is I'm going to write down what our vertex form looks like. Y equals a times x minus h squared plus k. All right, again, they give us the vertex. And just, again, be careful when you plug in with your signs. So first, we're just going to plug those in. So again, I don't know what a is, so that's going to stay a for now. Times x minus -2. Okay, so I just plugged it in for now. And then plus k, and k was 5, so that's plus 5. All right, if you feel comfortable just making that a plus right away, please go ahead. All right, I'm just plugging in like this so we can see where we get this from. All right, so again, just to simplify, we're going to have a x plus 2 squared plus 5. All right, and again, notice these are opposite. Right, when you have a positive 2 in here, your vertex is negative, but the k value stays the same. So now we're going to plug in the xy value we have to find out what a is. Right, so my x and y we have is 0 and 9. So right away, right, the equation is equal to 9. 9 equals a times the x that we picked was 0. So 0 plus 2 squared plus 5. Right, so again, remember these are going to stay there in the final equation. And all we're looking to do is find out what a is. So let's simplify this and solve. So 0 plus 2 is 2. 2 squared is 4. So we're going to have 9 equals 4a plus 5. And now we solve for a. Subtract 5 from both sides. Well, this one was pretty simple. A is 1. All right, so again, now you're going to go back here and you're just going to replace that a. So our vertex form right, and we don't even need that 1 there. X plus 2 squared plus 5. So we got a little time, so just with this last one, I'm going to take it a step further and do expanded form. So all we're going to do is we're going to FOIL that x plus 2 and then add 5 to it. So x plus 2 times x plus 2 will give me x squared plus 4x plus 4. And then we add 5. Oops, I don't need parentheses. So we have x squared plus 4x plus 9. Right? And those two are equivalent expressions. They are equal to each other. Any questions there?